finding the perpendicular bisector of a line. So the nice thing about perpendicular bisector is it does what it says on the tin. If we have a line AB and I want to find the perpendicular bisector of it, well, first of all, let's draw the line AB. So that's the original line AB. If I want to find the perpendicular bisector, what I'm asking for is a line which cuts it at 90 degrees perpendicular and bisects it. In other words, it cuts it in two pieces. And more than that, it needs to cut it in two equal pieces. In other words, it needs to cut it right down the middle. So bisector cuts it down the middle. In other words, these two lengths will be the same, okay? Right down the middle. Perpendicular means it's going to be 90 degrees. And I want to find the equation of this blue line here. That's 90 degrees there. So what do I need to do? Well, I know how to deal with perpendicular gradients. If I knew the gradient of AB, then I could just find the perpendicular gradient, and that would be the gradient of my line. So let's start with that. Let's start with AB. The gradient of the line AB of these ones here is y2 take away y1, so that's going to be 1 plus 7 divided by x2 take away x1, so that's minus 2 take away 4. So that gives me 8 over minus 6, or minus 4 over 3 once I simplify it. So that's the equation of, that's the gradient, sorry, of this line. Well, my line, my perpendicular bisector, is going to be perpendicular to it. So how do I find a perpendicular gradient? Well, if it's a fraction, that's especially nice because it means we just flip it upside down and flip the sign as well. So it's going to be, instead of minus 4 over 3, it's going to be positive 3 over 4. So there we go, that's the gradient of my line done. What else do I need? I need a coordinate that it goes through. So what coordinate does my blue, my perpendicular bisector, go through? Well, the middle of line AB is the midpoint of AB, so that's what I'm going to use here as well. Midpoint, or mid AB. And remember our formula, what we're going to do is we're going to add together x1 plus x2, add together our two x coordinates, 4 plus minus 2, and divide by 2, and the y coordinate is y1 plus y2. So that's minus 7 plus 1 over 2. So that gives me 2 divided by 2 is 1. That gives me minus 6 divided by 2 is minus 3. So now what I've got is I've got my gradient that I'm going to use for my line, and I've got a point that it goes through, so that's going to be my A and my B. So now all I need to do is the equation of a perpendicular bisector, y minus b equals mx minus a. And I'm just going to sub these in and we'll see where we get to. Okay, so I've subbed these in. I was careful, y minus b, but it's y minus minus 3, so that's y plus 3. I've now got this fraction here, and now I want to get rid of this 4, really. I want to get rid of a fraction. So a couple of ways I can do this. I can multiply it out first, perhaps. Now I can multiply absolutely everything by 4. So that's going to give me 4y plus 12. Multiplying these by 4 eliminates the denominator, which is what I was wanting, to leave me 3x, take away 3. And if I've started writing it this way with 4y and 3x, I probably want to write it all across to the left, starting with the x term. So that would be minus 3x plus 4y plus 3 gives me plus 15 equals 0. Or if you don't like leading with the minus sign, you could flip all the signs, and 3x take away 4y, take away 15 equals 0 is also exactly the same. So there we go, perpendicular bisector. Make a wee sketch, helps a little bit. Find the gradient of the original line, and then find a perpendicular. And for bisector, you want to find the midpoint of the original line, and that'll give you A and B values.